And solve the insert a node at a specific position in a linked list problem on HackerRank. In this problem, we're given a pointer to the head node of a linked list and an integer to insert at a certain position. We need to create a new node with the given integer as its data attribute, insert this node at the desired position, and return the head node. In this example, our head refers to the first node in the list, 1, 2, 3. We need to insert data 4 at position 2, and in this list, the position starts at 0, so this is 0, 1 is at 0, 2 is at 1, and 3 is at 2. We need to place data equals 4 at position 2, which is where 3 currently resides. Therefore, 4 is going to be placed between 2 and 3. And the final result is going to look like this, 1, 2, 4, 3. So 4 is at position 2, 0, 1, 2, 3. The way we're going to do this is obviously first and foremost we need to create a singly linked list node. So let's go ahead and do that. That stores our data. Singly linked list node. Let's call it new node is equal to singly linked list node with input data, which is what they gave us in the given. The first thing we need to account for is if the position they gave us in the given is at 0. And I'm going to use MS Paint to explain what we're gonna have to do. So with this brush, we have the original node head, and we have the pointer list, which is in the given. Let's just call it L. We created a new node. Let's call it N. Obviously, they both have next pointers. So what we're going to do is we're going to have new node dot next point to the head node. So what list points to. So new node dot next, simply put, equals to list. And then we're going to return our new node. So let's go ahead and do that. So if position is equal to 0, then new node dot next is equal to list, and then return new node. Okay, now we need to take care of any other position that they give us. If we go back to the example, like I said, we have a pointer list which points to 1. Let's actually go back to MS Paint. Let's remove all this and put the example they gave us. So we have 1 and 1 points roughly to 2. There we go. And then 2 points to 3. And we have list which points to the head node. Let's call this L. And we created our new node, which is 4. And obviously it has a dot next, which currently is null. Okay, so what we're going to do is we're going to create a new pointer, and we're going to call it current. So let's call this C. Because I don't want to change what list points to, in the end I'm going to return list, which points to the updated singly linked list, which has our new node data in its correct position. So instead we're going to create another reference pointer called current, which is equal to list, and we're going to update the current pointer in order to know where exactly we're going to place our new node. So what we're going to do is we're going to keep updating our current pointer. So current equals current dot next until we reach position -1. So this is position 0, this is position 1, and this is position 2. We need to place 4 at position 2. So we're going to keep updating current until we reach position 1. Once current points to position 1, as such, we're going to say that new node dot next is equal to current dot next, and current dot next, which current is right now points to 2, current dot next points to 3. Therefore, new node dot next is going to point to 3, like this. And then finally, current dot next, which currently points to 3, is going to point instead to our new node, and then this pointer right here will cease to exist. And we can return list, which list points to our head node, which is 1, 1 points to 2, 2 points to 4, and then 4 points to 3. So let's go ahead and actually do that on code. So let's go ahead and do that on code. First, we need to create a singly linked list node, and we'll call this current, which is equal to list. And okay, perfect. And then we're actually going to keep updating our current pointer, and the way we're going to do that is actually, first of all, we need to create an int count equals to 0, and then we're going to say while count is less than position minus 1, and current is not pointing to null, then current is equal to current dot next, and then obviously we need to increment count plus plus. So now with our current pointing to the position right before where we need to input our new data, what we're going to do is new node dot next is equal to current dot next, and then current dot next is equal to new node, and then we need to return list. So let's submit it and see if it worked. Is there an error here? So there is an error here. I just forgot to place new. So let's submit that again. See if it worked. As you can see, it ran through all the test cases, and therefore, yep, congratulations. So that was the insert a node at a specific position in a linked list problem. I hope you found that video helpful, and thanks for watching.